In this Databricks episode, I'm going to show you how we can implement liquid clustering on Delta tables. First, let's understand what is liquid clustering and what it is used for. Liquid clustering is a modern feature of Delta Lake that dynamically organizes data based on query patterns and selected columns without strictly relying on the traditional partitioning. It leverages techniques like Z-order optimization, which rearranges data files to cluster similar to data together, which improves query efficiency, cost efficiency, storage optimization, and simplified data management. Let's talk about what it is used for. Databricks recommend liquid clustering for all new Delta tables, which include both streaming tables and materialized view. The following are examples of scenarios that benefit from clustering. When tables that are often filtered by cardinality are in our dataset, then we can use liquid clustering on them. Tables with significant skill in data distribution, tables that grow quickly and require maintenance and tuning efforts, tables with concurrent write requirements, tables with access patterns that change over time, tables where a typical partition key could leave the table with too many or too few partitions. Now, before we go into the demonstration part, I'm going to please implore you to subscribe to this channel and toggle on the bell icon to be informed of new videos. Let's go into the practical side of things. All right, so I'm currently in the Microsoft Azure Databricks data platform. Now, the first thing I want to check is whether I've got a cluster that is up and running. Now, we need a cluster to perform our data processing in our Databricks notebook. So to investigate, I'm going to click on the compute, and then I've got this my cluster, which is currently running. Now, if you don't have any cluster, just click on this create compute and then provide all the details and then click on the create at the bottom, and that should be ready in about 5 minutes. So since we have a cluster that is up and running, I'm going to come to this liquid clustering in Databricks notebook. Now, before we go on, it is important we attach the cluster to this notebook. So this is already attached. And before we write our code, I want to show you what I've got in the sales catalog, Unity catalog. So when I expand, I can see I've got this default information schema, sales schema. Now, we don't need any of these three schemas because we're going to create a separate liquid cluster schema that's going to be resident in this sales catalog and then proceed with the data processing. So we want to come to this and create a new code cell. And I'm going to start by typing spark.sql and open a bracket inside double quote. I want to write create schema, and the schema is going to be resident in this sales catalog. So the convention is we have to provide the name of the sales catalog and then the name of the schema. So sales underscore catalog dot, and then we can give a meaningful name to our schema. I'm going to call this one liquid clustering schema. And then I can hit the control enter to run this piece of code. So this executed, and then we've got this data frame. Now, for now, we do not have the liquid clustering schema because we need to refresh the catalog. So I'm going to click this refresh, and then I can expand the sales catalog. I can see the liquid clustering schema with no data in it. That's cool. We want to go ahead and generate a sample data. Now, let me quickly collapse this. So basically, we're going to be importing all of these libraries, and then we have this piece of code that is generating the sample data randomly, and then we have this piece of code that is creating columns. So we're going to have the transaction ID, region, product, customer ID, transaction date, and the amount. And then we are creating a Spark data frame, calling the data and the schema, and all of these are stored inside this df variable. And then we are using the display function to display the content of the variable. So I'm going to press Control Enter to run this code, and let's see the result. Okay, so we can see we have our table. We've got the transaction ID, region, product, customer ID, transaction date, and the amount. Now, we want to go ahead and partition and cluster using column with low cardinality and write to Unity catalog as a delta table. Now, a low cardinality column used in clustering has a limited number of unique values, while a high cardinality column used in clustering has a large number of unique values. Now, let me quickly show you what I'm talking about. We have this region and the product column. Now, the region contains 4 unique regions: west, south, east, and north. And then the product contains 4 unique products: we have blender, smartphone, we have TV, and laptop. So these are considered as a low cardinality column because they have a very limited number of unique values. Now, when we're talking of a columns that contain high cardinality, we're going to be talking about the transaction ID and the customer ID because these contain quite a large number of unique values. So we're going to go ahead and start by partitioning and clustering by column with low cardinality. Specifically, we're going to be using the product column. We can even use the region, it doesn't matter. So I'm going to come here and create a new cell, and then we can do df dot right and then dot, and we can use the partition by, and then open the brackets. So we're going to partition by inside double quote the product column, and then we can use the dot save as table. So we're going to be saving as a delta table, and then we want to save it right inside this liquid clustering schema. So I'm going to click on this kebab and then copy the schema path. So inside this place, I'm going to type in a double quote and paste, and then I can use dot, and then I can provide the name of the table. So I'm going to call this one partitioned by product. So this is sorted. Now to speed things up, I'm going to copy this and I can paste the code. So now I'm going to use the cluster by, and then we're going to be clustering by the same product column, and then I'm going to just change this to clustered by product, and then we can run the two codes. So press Control Enter. Okay, so the code executed, and I'm going to click on this refresh. So when I click on the refresh, I can expand the sales catalog, I can expand the liquid clustering schema, and then we can see the partition by product and the clustered by product. Now, when I hover my mouse on the partition by product delta table, we can see that the partitioning created a total number of 32 files, which sum up to 244.9 kilobytes. Now, this can cause what's called a small file problem in the future. So when I hover my mouse on cluster by product, we can see this is just 146.8 kilobyte, which is quite smaller, and it's only creating a single file. So this is one of the reasons why Databricks highly recommend not using the partitioning but clustering. So now let's carry on. So since we have this done, now we can go on and run and optimize and run the query on top of the partition and the clustered by tables. So I'm going to create a new cell, and I'm going to use the magic command SQL, and then I'm going to type in optimize, and I'm going to copy this fully qualified 3 namespace, Control C, and I'm going to paste here. And I'm going to copy this also to the clipboard, and I want to create another cell to run an optimize command on top. So the magic command SQL, I can type in the optimize, and then I'm going to paste the code. So let's run this partition by product, Control Enter, and once that is done, I can run this clustered by product, and then we can compare the output. So I'm going to come in and press Control Enter to run the clustered by product. And let's take a look at the partition by product. So basically, we have the two columns, the path and the metrics. Now, I'm not going to focus on the path. I'm going to quickly move this down a little bit so that we can see the metrics. Now, when I expand the metrics, we have the object number of files added, which is 4, number of files removed, and then we can see the files added, minimum, maximum, average, total files, and then we can see the files removed, minimum, and so on and so forth. So we have all of this metadata for the partition by the product, and then we can see so many other information. At the bottom, we have the deletion vector start, and then we have the number of deletion vector remove 0, and so on and so forth. So let's go ahead and check the output for the clustered by the product. So again, I'm going to move this to the left, and I can expand the metrics column. So basically for this, we have the number of files added 0, number of files removed, and then we have this files added, and so on and so forth. Now I'm going to quickly scroll down, and then let's focus on the clustering metrics. I'm going to expand this, and then we can see we have the size of table in bytes before lazy clustering, which is about 150,296, and then we have all other metadata. Now we can go on and query the two tables. So I'm going to copy this fully qualified name, and I'm going to come in and create another cell at the bottom. So I'm going to write in select star from, and I'm going to paste the code. So you can see I do not included this magic command because the Databricks notebook is so smart to understand that I'm writing the language, the SQL language. So it automatically includes the magic command for me. That's cool. So I'm going to press Control Enter to run this partition by product. And let me quickly go up and copy the clustered by products fully qualified namespace. Control C. I'm going to come back here and then I'm going to paste the code by writing select star from Control V and then Control Enter. So then we can compare both results. Now for the partition by product, we have this 1.23 runtime. So let's see the clustered by. So for the clustered by, this actually executed in just 92 milliseconds. Now we can see that there's quite a few difference in terms of the runtime. Now the difference is actually not much on a low cardinality column like the product column. Now let's see how we can see much difference when we use a high or large cardinality column. So I'm going to quickly go up quickly and let me copy this code here and make some changes. So Control C and I can come right here. So we want to partition and cluster by using a column with high cardinality. So create a new cell, Control V. Now I'm going to change this to transaction ID column and I'm going to copy that quickly and paste in this clustered by Control V and I'm going to call this one partition by transaction underscore ID and I'm going to do the same thing here. I'm going to call this one clustered by transaction underscore ID and then we can control enter to run the two codes. So this executed in about 4 minutes. That's cool. So we want to go ahead and optimize and query the partition and clustered tables using the high cardinality columns that we specify. So I'm going to come in and use the magic command SQL and type in the optimize. And then we want to start by optimizing the partition by transaction. And let me quickly copy the clustered by the transaction and I'm going to create another cell, use the magic command SQL and then we can write the optimize command and then I'm going to paste. So for the partitioned by transaction ID, I'm going to press Ctrl Enter to run the code. And then for the clustered by transaction ID, I'm going to go ahead and Ctrl Enter as soon as this executed. Okay, so I'm going to press Ctrl Enter. And then we're going to see the difference also. So again, we have the metrics and then we're going to have the metrics for the clustered by column. So let me just quickly show you the metrics for this. So when I expand again, we have all of these number of files added, removed, and so on and so forth. And then we can always see the deletion vector start and then the cluster metrics and so on and so forth. So we want to go ahead and describe the partition and the cluster table. Now, before we describe, let me quickly show you something. I'm going to quickly refresh this catalog and I'm going to expand the sales catalog, expand this. Now, let's focus on the partition by transaction ID. So when I hover my mouse on this, let's see the details. Whoops, we can see we have 10,000 files and this amounts to 14.2 megabytes. Now this is quite a huge small file that's been generated by the partitioning and this can cause a small file problem which is actually not good, and of course it can actually impact performance of our query and cost a lot of storage cost. So that is why Databricks highly recommend not using the partition by but the cluster by. Now when I hover my mouse on the clustered by transaction ID, you can see this is just a single file of 149 kilobytes. So this is actually good. Now let's go ahead and describe the two tables. So I'm going to quickly copy this, just copy this to the clipboard and then we can go down and use the okay, let me create another cell here and we can use the magic command, the %SQL, and then we can use the describe and then we're going to use the extended keyword and paste and Control Enter. So let me just copy the clustered by also and then we can compare the description. So I'm going to quickly come in and this is what I'm looking for. I'm going to copy this and I'm going to scroll down, create another cell at the bottom here. And then we can use the magic command SQL describe and then extended keyword Control Enter to run the code. Okay, now let's see the partition by the transaction ID. So for the partitioning, we're going to have all of this column name and the data types similar to the clustered by, but the difference is that we're going to see the partition information. So for the partition information, we're going to see the transaction ID, column name, and the big int data type name. And we are going to see the delta statistics. We have the column name and the column selection method, which is first 32, and some other information such as the name of the catalog, name of the schema, that is the database, the name of the table, time created, and so on and so forth. And then we can see the location. Now let's quickly see the clustered by description. So for this, we're going to have similar column name, the data type, since we're using the same data. And then we can see the clustering information. So for the cluster, we're going to see the clustering information. For the partition, we're going to see the partition information. So again, we have the same number of columns. And then let's quickly scroll down. Let's pay attention to the information at the bottom of the table properties. Now, when I expand this, I can go down a little bit. We have the clustering column, so we can see we have transaction ID, and then we have the delta.checkpoint policy equals to version 2, delta.enable deletion vector equals to true. So these are key important metadata that improve our data as we use the cluster by. Now I'm going to scroll down, and then we want to move to creating a cluster by using the create table as select from the partitioned table. So I'm going to create a new cell, and I'm going to write the standard create table, and I'm going to call this one clustered by partitioned table. And then I'm going to use the cluster by keyword, so cluster by, and then we're going to be clustering by the transaction ID column, and then we're going to use the as select star from the sales catalog dot liquid clustering schema dot partition by transaction. So I can run this create as select, control enter to run the code. So we can see we have the number of row affected and the number inserted rows. So I'm going to refresh my catalog, and then when I expand this, I can see the default schema, and then I can see the clustered by the partition table we just created here, which is absolutely cool. Now, when I hover my mouse on this, I can see that we have 147 kilobyte and a single file, which is absolutely cool. Now, I can go on and move that a little bit. So what about if we want to get rid of the cluster from the cluster table? We can do that. So I'm going to quickly copy this, and I'm going to scroll down a little bit. Now I'm going to use the alter table, and I'm going to provide the name of the table, and I'm going to use the cluster by none. So the none is going to actually get rid of the cluster that we applied in the intermediate step. So press Ctrl Enter to run the code. So we can see this gave us okay, and then when I refresh this, or let me quickly come to this tab, and let me go to the catalog, and I can go to this, I can expand, and then I can click on this the default, and I can click on the cluster by partition. Now I'm going to come to the details. That's where the information is, and then when I scroll down, I can see that we do not have any clustering columns. So we can see this actually nothing. Now, let me quickly go back and just cluster by 2 columns. So I'm going to come here, and then I can get rid of this none. I can inside double quotes get rid of that none. Let's say I want to cluster by the transaction ID, comma, the amount, and I can press Ctrl Enter to run this code. So we can see this is going to show okay. So when I come back here and watch this side, as soon as I refresh, we're going to see the 2 columns. So we can see we have the transaction ID and then the amount. And when I come back here, let's say I want to add the region, and I press Ctrl Enter. So this executed. When I come back here and I refresh, and we're going to see the region. Let's just add amount, and now it's going to fill in a moment. So press Ctrl Enter to run this. So we can see found duplicate. Oh, sorry, let me just check. This should be like the product. So I'm going to type in the product and then press Ctrl Enter. That's actually a good one. So you cannot run a duplicate column. So this is okay. I can come back here, I can refresh, and then we can see the product column, and let's add the transaction or the customer ID. So I'm going to put in customer ID column, Control Enter. Okay, now this is what I'm looking for. So cluster by for liquid clustering support up to 4 clustering columns, but the table has clustering columns. Please remove the extra clustering column in order to be able to proceed. So that's one of the limitations that is associated with liquid clustering in Databricks. So I hope you've learned something in all of this tutorial. If you like this video, please give it a thumbs up, share with your friends, comment, and subscribe to this channel. Thank you for watching. Bye for now.